Hey guys, welcome back. We're going to be quickly going through the end of our S4 notes, which finishes up the whole year and finishes up the chapter on sequences and series, which was the topic we introduced yesterday. A series, if you recall, is just a list of numbers, but instead of just keeping it as a list, say like 3, 6, 12, 24, 48, 96, we are adding up sequential terms in that list to find one total. And the backside of your notes just goes through several examples after we figured out that there is a formula, kind of a shortcut, to help us out with adding a greater number of terms. It makes it go faster, it's much more accurate. We're just going to practice that formula. So I know several classes did problem number 5, but this would be a good review if you didn't get it down yesterday. So our formula, if you need it, starts off with Sn equals. That just means a series or a sum. And we need to know A1, where the list starts. If you recall, there are two sets of parentheses. Both of them have 1 minus r inside, but those would cancel out otherwise. The top group is a little bit different because it has n as an exponent. If I go ahead, I know A1 is the first term in my series. That's going to be 3. So I will have to put in 3 here in the front. Then I need to figure out, well, what type of list is this? All of the questions that we're doing are geometric, but the pattern to move from number to number, my R ratio is doubling, times by 2, times by 2, times by 2. So both of these are going to be 1 minus doubling, 1 minus doubling. But because I am adding the first 13 terms, and this would be S13, if you will, I need to raise that top 2 to the 13th power, which is a little bit different. It's not 13 minus 1, so there is a n minus 1 in some of the other formulas, but not in this formula. So typing that in, it's pretty easy. I usually like to go ahead and do the top parenthesis group first. So we have 1 minus 2, and that needs to be to the 13th power. We're going to get a very large negative number, negative 8,191. And you may be saying, wait a second, how are we adding things up and getting a negative amount? None of these are negative, they're all positives. And that is a little weird. The bottom of this, 1 minus 2, creates negative 1, which kind of solves that problem. But if you really figure out like where this formula comes from, there's some rearranging going on, which sometimes can cause you to be negative in the top even though your answer is positive. So 3 times that negative amount, and then divided by negative 1, obviously just changes and takes the negative sign away, we end up with 24,573. Hopefully that's not too hard, and once you understand where to put things, it's just committing this formula to memory, like the others from this chapter. So let's talk about number 6. We need to find the value of this series to the 7th term, and they gave us the start of this example, negative 45, positive 135, negative 405, so subtracting, plus 1,215, and it keeps switching back and forth, back and forth. So this is geometric. My A1 value is negative 45, that's what this list starts with, and my R, the common ratio, if I try to figure out what to multiply by and what to multiply by, it's going to be a negative number since it switches back and forth between positives and negatives, and it's tripling, so negative 3 is my common ratio. So finding the series of the first 7 terms, S7, I start at negative 45, I multiply by these two groups. The groups are 1 minus, and then I need to put negative 3. And I actually will move this so I have a smidge more room. 1 minus negative 3. And you may be saying, like, can we just write it as plus? Absolutely, but I would be careful because this top negative 3 has an exponent, and so you may not always end up adding. So the exponent takes priority over everything. And in this case, the exponent is 7. So the exponent of this always happens first. So typing that in, 1 minus, make sure that you're putting parentheses because -3, negative tripling, to the 7th power, that is going to end up as a negative amount. Whereas if I were adding an even number, taking a negative to an even power ends up positive. So the end result, creating a negative of a negative, is 2,188. And keep in mind, that's not my answer. That's what -45 is multiplied by. The bottom of this fraction, 1 minus a -3, just creates 4. And so we can go ahead and we can multiply by -45, press enter, divide by 4. You could also do it in just one step, but I like having it split up there. And our end result is negative 24,615. Now, does this make sense? If I kind of look at the progression of my numbers as I go further out, the odd amounts here are negative. Every odd position is a negative number. The even positions are positives. So actually, if I'm adding 7 terms, the last thing that I'm adding in is a very large negative amount, which is why I probably total up to be a negative answer. If I added up an even amount, perhaps that last number would pull it back to have a sum that is positive. Let's try 7. We need to find the value of the series to the 8th term, so that will be S8, for the following sequence: 1/3 plus 1/9 plus 1/27 plus 1 over 81. So the pieces I'm adding get progressively smaller. So to start off, I need to go ahead and I'm putting 1/3 as my A1 value. I'll make my 2 sets of parentheses down below, 1 subtracting, and then I just need to figure out R. Because I'm getting smaller and smaller, I am dividing by a certain amount. Each one of these is divided by 3, but that would have to be a common ratio of 1/3. Okay, so I am taking 1 minus 1/3, and I do like putting that in parentheses, at least when I have an exponent. Since I'm finding 8 numbers to add up, I need to take 1/3 to the 8th power. This can sometimes be a little tricky, so maybe we should do 1/3, 1 divided by 3, and raise that to the 8th power. And you'll notice I'm getting something very, very small. It actually has scientific notation. E to the -4 is times 10 to the -4th power, so I need to actually move that decimal place 4 spots to the left. Now if I take 1 and I subtract that answer, I'm getting 0.99987. Okay, so that's going to go after the 1/3. I'll just put ... there for you. 1 minus 1/3 on the bottom is actually just 2/3. And now if I go ahead in my calculator and I take that answer times by 1/3, and then divided by a fraction, it's the same thing as multiplying by its reciprocal, so I could multiply by 3/2, multiply by 1.5, or I could also just divide, like it says to do, divide that by 2/3. Okay, there's more than one way to solve some of these problems. And so the final answer, 0.49992. Now, just like with exponentials and logarithms when we were in that chapter, if you'd like to include 4 decimal places, that would be good. That way I know that there's a certain level of accuracy in your answers and you didn't go wrong in what you typed into your calculator or any of that process. That would be great. So actually, as I add up these numbers, you can kind of see that I'm getting closer and closer to 1/2, which is kind of an interesting idea, that you can add things up and get close to a nice whole amount, even though this problem you'll never quite get there. So what about problem number 8? Can we find the sum of the series to the 14th term, so S14 if you will, for the following sequence? And they give us some information right over here. This is our explicit formula. Okay, we have n minus 1 as an exponent. This first number is A1, so we start at a quarter, 0.25. And then the 2 that's has the exponent attached to it, that's our base, that's our pattern. So I'm doubling. The ratio is multiplying by 2 every single time. If you need to write out the list itself, you can. There's nothing against that. So this sum will start with the fourth. It'll have 1 minus. I'm doubling. I need to take that to the 14th power, since there are 14 numbers in my series. And then the bottom is also 1 minus 2, but there's no exponent there. So if we type this in, let's clear everything out so you guys can see that. So 1 minus 2 to the 14th power. This should be like taking 1, subtracting a very, very large number. So I'm expecting a negative amount, negative 16,383. Then on the bottom, 1 minus 2 is negative 1. So all I have to do here is take this answer, I multiply it, or I could divide by 4, multiply it by 1/4, it's the same idea. And then just go ahead and divide by negative 1. So in the end, if I keep adding up these numbers, first number through the 14th number, I get 4,095.75. Which kind of makes sense. If I start with a quarter and keep doubling and doubling and doubling, some of those numbers are going to get kind of big, and so I should have a larger amount in the end. Let's try question number 9. Find the sum of the series to the 11th term, so S11, if the sequence has this information. Now here, AN equals 3, AN minus 1 is saying wherever I stand is equal to 3 times the prior position from where I was standing. And then they say at the end, A1, the list starts with 2 as a value. So this 3 here is the common ratio. This is our recursive formula. And between the recursive formula and the explicit formula, you have to have those memorized. You have to know how they work, what each piece means. So A1 being 2 means I start with 2. I will triple and triple and triple. So 1 minus 3 to the 11th power. And then that's going to be over 1 minus 3 without a power. If I go ahead, I'm going to have 2 times probably a very large negative number. And then 1 minus 3 is negative 2 on the bottom. I get negative 177,146. And what's kind of interesting about this situation, the 2 and the negative 2 that are out in front are going to cancel, and then actually the negative and the negative cancel as well. And so I'm just left with the positive version of that number. So 177,146. The work that I'm showing kind of through these problems is the work that you will need to show as well. It's not a ton of work, but you know, show me this. This is important so I know exactly what you were thinking about and that you know the structure. Very last question on the notes. Last question of the year, really, for notes. Find the sum of the series to the 20th term. So S20. If we have this information here at the end. This is our explicit formula. So it starts off with a 1. The negative 1/4 is my R. It's my ratio. So this would be an alternating pattern between positive and negative values. And actually it's decaying. It's getting smaller because multiplying by negative 1/4 is really dividing by 4. So everything gets small, 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 and alternates at the same time. So really kind of a crazy idea. Putting the numbers where they need to go, negative 256, 1 subtracting. Make sure that you keep negative 1/4 in its own set of parentheses. And that amount will be to the 20th power. Very important that you layer things correctly. The bottom will be 1 minus that negative 1/4. So if I go ahead and maybe just look at the bottom at the moment, 1 and then subtracting a negative makes those positives. 1 plus 1/4 is 5/4. If you wanted to say 1.25, it's the same idea. We'll get negative 256 in front of probably some weird numbers. So I'm going to keep those parentheses a little bit more open for us. Let's go ahead, clear everything out. So parenthesis, 1 subtracting, and then we'll put our negative 1/4 in parentheses as well, just to keep it as a number. A negative value, if I raise it to an even exponent right there, should produce a positive, because it's an even amount of negatives that all cancel. So I'm going to have 1 minus something that's positive, not 1 minus a negative. So that's a pretty important fact. That needs to be raised to the 20th power, and then I'm closing that, so it's the big parenthesis at the end. And pressing Enter, this is interesting, it says 1. So one thing that's kind of weird, negative 1/4. If I go ahead and raise that to like the 10th power, let's say, it is already so incredibly small. So 9.5 times 10 to the negative 7 power would be 6 zeros with the 7 afterwards. That is just 1/4 to the 10th power. If I'm taking and multiplying by 1/4 10 more times on top of that, it's only going to get smaller and smaller and smaller and smaller until it's like basically 0. So I'm taking 1 minus basically 0, and that's why my calculator gave me this top answer of 1. Okay, so it's 1, I guess, in quotation marks, if you will, because very, 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 very close to 1, but not technically 1 itself. The calculator just kind of gives up, doesn't have enough precision. So I'm going to go ahead and take negative 256 times that, basically 1, and then divide that by 5/4, or divide that by 1.25. And so my answer in the end, and keep in mind, this is not the true answer, because it's basically this answer. We're so close it's hard to tell the difference, is negative 204.8. So if you wanted, you could put the squiggly equal signs. That means approximately equal to negative 204.8. If you just do equals, I am okay with that as well. But kind of some interesting things happening there. The fact that we multiply a fraction so far that it is basically giving you 0, nothing. And then 1 minus nothing is basically 1. I don't think that there should be too many problems like that on your homework or anything, but it's good for you guys to hear and walk through some of the different steps. A few of these can be tricky, but the more you practice with any of these formulas, the better off you'll be. So the rest of class today is for you guys to be working on any homeworks from this chapter. Tomorrow we'll have a day to work on study guides and to prepare for our test that's coming up. But hopefully you guys have a pretty good grasp on sequences, lists of numbers, and then series if you total up those geometric lists. Thanks, guys. If you have any questions, let me know, and I'll see you next time. Take care.